Hello, today we are going to go through the key points in Chapter 2 and Chapter 3. Before we begin, I think we should familiarize ourselves with the tools and software we are going to use. They are FreeRTOS, which is an open source library for real-time operating systems for microcontrollers. Basically, it helps you to do multitasking and task priority in microcontrollers. LibOpenCM3, which is an open source library that contains APIs that allows you to interact with the ARM microcontrollers. GCC ARM Cross Compiler, which is an open source cross compiler that allows you to generate machine code for ARM microcontrollers from your computer. And finally, ST-Link, which allows you to flash your code into the Bluepill. With this software, we are going to code, build, and flash the project into the STM32 Bluepill. So, Chapter 2 covers the software setup. I followed the instructions on the book about the software setup and managed to get everything up and running. The only issue I encountered is finding and downloading the GNU ARM Cross Compiler toolchain, as the instructions from the book might be a bit outdated. It tells you to go to the Developer ARM website, and from there, navigate to the Free Software and Linux section. But as you can see here, the section doesn't exist anymore. So over here, I will show you how to do it. Just go to Google and search for GNU ARM Cross Compiler toolchain download. Okay, and then press on the first link here. Okay. Scroll down over here and then download the one that suits your operating system platform. For my case, it is this one, the 64-bit Linux. Right after this step, you can continue off from the book at step number 6. And everything should work after that. So once you have all the software ready, it's time to hook up your Bluepill to the computer, which is what you will do in Chapter 3. Chapter 3 talks about powering up the Bluepill and using the ST Flash utility. It is a relatively short chapter, but there are a few key takeaways. The Bluepill natively works on 3.3V, and there are two ways to power the Bluepill, either from the 3.3V power pin or the 5V USB port. Either way is fine as long as the input voltage is enough. And you need to follow the one power source rule, which is just to supply the Bluepill with only one power source. So don't power the Bluepill from both the ST-Link V2 and the USB port, otherwise you might risk damaging it. There's also a bit of discrepancy in the ST-Link V2 diagram shown in the book and in my ST-Link V2. Like over here, where pin 2 in the diagram shows the data pin, while in my actual ST-Link V2 it shows the clock pin. Still though, as long as you follow the pin and correct the markings correctly, everything should still work. Now it's time to hook the Bluepill up to your computer, and once everything is wired up correctly, you should be able to run the following commands. Probe, which is to get more information about the Bluepill connected. Read, which allows you to save an image copy of the program that the Bluepill is currently using into your computer. Erase, which erases clean the flash memory, and flash to flash an image to the Bluepill. So I'm going to do a short demonstration of that next. First, I will do a quick probe, and it's uploading me some information over here about the Bluepill, which is a good sign. Now, I will save the default flash program into an image. Okay, now let's erase the flash memory in the Bluepill. Notice that the blinking light freezes, and now I'm going to flash it again. And yep, it's back blinking. If you read up to this chapter, give yourself a pat on the back and be prepared for more. The next few chapters will be going through more of the STM32 Bluepill capabilities, and there will be more example code to come. Stay tuned, keep on learning, and goodbye!